Okay, so it's called percentage purity. Oh, wait, it might be helpful if I am casting to the screen. This idea of percentage purity. Okay, so the idea is that if I have a substance here, it may not all be the actual substance. Some of it, some portion of it, might be something else. Okay? That makes this substance impure. Okay? That makes sense? Right? It's not completely one substance. It is impure of some sort. Right? So, if it's impure, when you react it with something else, okay, only the stoichiometric amount is going to react, not the total amount. So effectively, if I said I had 10 grams of this substance, but only 8 of it was pure, 8 grams was actually the substance, black, and 2 grams red being the impurity, would I use the 10 grams or the 8 grams or the 2 grams to work out the number of moles of whatever I've got here? Which one? The 8, the 2, or the 10? Which one should I use to work out the number of moles of stuff that I've got? The 8. So then I would use this to work out the number of moles, which would then lead to the number of moles of this one here. I would not use the 10 because it would give me too much of that other stuff, okay, that I would need. So the most simplest way that you can be shown that something is impure and how much is there is by saying that, okay, there is a certain percentage, like this is saying this is 80% pure, right? And so you could apply that 80% to the 10 grams to work out how much is there. Everyone happy with working with percentages, yes? All right, okay, cool. The next concept is that if I have something that I don't know the proportion that is pure and the proportion that is impure. I don't know how much is pure or how much is impure, right? But I know that it will react with something else, so I react it with something else. And then I know that it's going to form other substances here and here, all right? Other substances. Okay, now, the amount of these other substances can tell me how much there was in the beginning or how much of the pure stuff there was at the beginning, right? So, let's just say that the reaction is A plus B goes to C plus 2D, okay? That's the balanced equation there, right? If then I say that I have 4 moles of C produced, how many moles of A would there be? 4. Good. And how many moles of D would there be produced? 8. Happy with that idea? Right? So, if I can work out this 4 moles turns out to be 14 grams, and the total mass was 20 grams, I can work out the percentage purity of that sample. Okay? So let's go through the steps here. What do we do? We have an equation. That's the first thing. We then have the number of moles of a product of some sort. It could also be the amount of moles of a reactant that was consumed. But generally, it's just not the number of moles of our unknown over here. It's not the number of moles of unknown over here. Okay? So, we have the number of moles of a product, which then we can use to work out the number of moles of our unknown, which then we can use to work out the number of moles of the mass of our unknown, of the pure part of the unknown. Okay, so this is the pure part, right? And then we can compare it to the total mass to work out the percentage. 14 over 20 is what, like 70%? Is that right? 70%. 70% pure. Because you've worked out the number of moles of a product which is produced, then worked out the number of moles of the reactant, then worked out the mass of it, then worked out its mass over that thing. There. Okay? That's the last step. Being able to either apply a percentage going forward. So say I have 10 grams and it's 75%, so you know that it's pure, so you only know that it's 7.5 grams. Okay, so that's just the first part going forward, which then you can use that to work out all the reactants and stuff and all the other products. Or if you don't know what the percentage is, then you can use the mass or the moles of a product to work backwards to work out the mass of pure substance of that reactant, to work out and compare it against the total to work out the percentage purity of it. Okay? Happy with that idea? Yeah? Yeah? No? No? Yeah? No? Yeah? Let's go through. Determine the balanced equation for this reaction, number 1. All right, so let's work out a balanced equation for it. So I've got H2SO4 and 20 grams of impure sulfur goes to sulfur dioxide and water. Okay? Can we balance that equation? Go, balance that equation. Okay, let's go through how to balance this equation looking at some principles here. The number of oxygens in this must be a multiple of what? 4. How do you know that? Good. There's a H2SO4 over here, which means that, and since there's no oxygens in this one over here, therefore, whatever coefficient you put in front of this, whether it's 1, 2, or 3, or whatever, has to be a multiple of 4. All right? This coefficient over here, this H2O, therefore, has to be an even or an odd number. An even. Why? Because it has to be a multiple of 4, and so therefore it must be an even number for it to be a multiple of 4. So this must be an even number here. All right? You know it can't be a 1 because you can't easily balance it with a 1 anyway. All right? Because you might have tried, okay, I've got 2 sulfurs on this side, so I just put a 2 over here, and now I've got 5 oxygens, but I've got 5 oxygens on the right, but 4 oxygens on the left, so that can't work. All right? So we immediately know that the coefficient of 1 can't be here. So this being the most complex thing, I should make that a coefficient of 2. Right? Which one do you think is actually the easiest element to balance? Sulfur. Why? Sorry, what? Well, kind of, but you've also got something all by itself. If you've got something all by itself, you just put any number next to it and it will balance it out. But the idea is that the H2SO4 is the most complex, so we should start with that one. So 2H2O will balance out the hydrogens. Then I've got 3 sulfurs on the left-hand side, right? But if I put a 3 here, it'll get to 8. If I put a 3 there, that'll be the correct number of sulfurs. And I will have 8 oxygens, which is then balanced. Yeah. Okay? That's the thinking. Look at the substances and say which numbers have to be odd and even. What do they have to be multiples of? Okay? Things like that can help you work out how to balance it a little bit faster. So now I've got a balanced equation. I have 20 grams of this, but it's impure. So I have some amount that is pure and some amount that is impure, or is the impurity. If 97.1 grams of sulfur dioxide, which is over here, 91.2 or 97.1 grams, 97.1 grams of sulfur dioxide was produced in the reaction, determine the mass of the pure sulfur present in the sample, and then determine the percentage purity. So again, you've got the mass of a product. So you can work out then the number of moles of that product. The number of moles of SO2 is equal to, what equation shall we use? What equation shall we use? Little m over big M. What should I put at the top of that fraction? 97.1 over the molar mass of sulfur dioxide, which is 64.06. Okay, and that gets me a number. We'll call that A. Right? Because ideally you should be remembering how to save numbers in your calculator, and you should save it as A because A is first. Right? So, I have the number of moles of sulfur dioxide. What should I look for next? The number of moles of sulfur. Good. Okay, so remember from back up here. Oh, whoops, I'm not even recording. Oh, god damn it. Okay, so from back over here, I've just done this one. I've got the mass of something, and now I've got the moles of it. Okay? So now I've got to go to here. That's where I'm at. Step 3. Okay? So, the number of moles of sulfur will be equal to the number of moles of sulfur dioxide times what fraction? What fraction? What fraction will it be, Cassidy? Is it unknown over known or known over unknown? Unknown over known, so therefore?
Unknown.
Which is what?
Which is the unknown.
Look at the equation. What are we solving for? S or SO2?
S.
S. So that is our unknown. Okay, because we have the number of moles of SO2, it's A. Yeah? So it's our unknown is the S. This is our unknown. This is our known. So therefore, if I want the coefficient ratio of the unknown over the known, what should I put down? What's the coefficient of S? 1. And what's the coefficient of SO2? 3. That's what I should write down. Okay, A on 3 is your answer, and that, let's just call that B. And then I have to work out what then, okay, because we've just completed step 3. What's step 4? We need to work out the mass of the pure part. So I need to know the mass. The mass of sulfur will be equal to, well, first of all, how do I rearrange that equation up here? How do I rearrange that equation over here to get me the mass? Oh, sorry, what? N times big M. Okay, so it'll be B times 32.06, which I'll just go call C. And that will be the answer to the mass of pure sulfur. And then the percentage purity, so the percentage of sulfur will be equal to C over the 97.1, which is the amount, no, it's not the 97.1. What number should I use? The 20, good. Okay, and then times that by 100 to get the percentage, which we'll call D, which will be equal to 81%. Look, I put answers on this one. Look. Okay? Happy with that process-ish? Jessel? Sorry, what? So there's no coefficient because you don't put coefficients when it's 1. So the coefficient of that S is 1. Are you asking that, or are you saying that that equation is not balanced? You're happy that the equation is balanced? Sorry, what? Yeah, there has to be no coefficient in this to be balanced. No coefficient in front of the S to be balanced, yeah? You feel happy that that's balanced? I can't count, sir.